All right, it's 11:20. Let's get started. So this is LWIG. If you're not in this room for LWIG, you may leave the room. Unfortunately, Zen could not join us either physically or virtually. So this is Mohit. I'll be handling all the administrative issues, and we have Suresh, our AD, here to help us along. It's already Wednesday, so I hope by now you know the note well. If you have some questions, come to the mic now or leave the room. So we had some time. I thought we could do a little bit more, spend some more time on the working group and how it has been progressing in the last, since the last IETF. So we had updates to the neighbor management policy document which Rahul will present today. Then we had an update to the TCP constrained node network draft, which was also presented in TCPM. We were hoping to issue a joint working group last call with TCPM, but there were some issues raised which Carlos would present today. So I guess we need another revision for this document before we do the working group last call. Then we had a new working group document adopted, and Rene will present more on this remotely during the meeting. There were no updates to working group documents on lightweight co-op implementation. So I had some feedback for the authors. Since we have all these new options and extensions in co-op like hop limit and too many responses, maybe it would make sense that at least some document tells me which ones should I implement for which scenarios. So if it's very small sensor, do I need to implement too many requests? Do I need to implement hop limit, for example? So I'm hoping Olaf or Matthias can use this feedback and bring an update of the document to the next meeting. We had no updates to the LWIG security protocol comparison. I guess they are waiting for IETF103 to stabilize before they come up with the numbers. Then we had the device classes draft, which is not yet a working group draft, but there has been some interest. We will have a last minute addition to our agenda. So we will have a presentation from Pascal. Pascal, who will talk about device classes for software updates. Then we had this draft IETF LWIG cellular, which is now in misref for more than 1,000 days, which is a bit sad. So I discussed with one of the authors, Yari, whether it makes sense, and this is Suresh also a question to you, to move all the normative references to informational. This is an informational document. I don't see any reason why we should be stuck on resource directory people to finish their things. And it's not like we can wait one more IETF and it would be done. I think it would be another couple of years before resource directory moves forward. So maybe the authors and AD can say something on this.
Suresh Krishnan. So as AD, the one thing I can do is like kind of pull it out of the RFC editor queue and push it back to the working group, do the changes and bring it back, right? Like there's really, I don't want to make this change in outside the working group process. Okay, so if that's something you would like we can probably just like pull it back and do this, and I can talk to the IESG about it. And so one thing I want to talk about is really the normative reference in informational documents. I think it's not that straightforward, right? Like, just saying this informational document and we don't need normative. But if you think like somebody can follow this document without reading that, then we can seriously push it to informational, right? That's really the question. So that's a different question than saying this is an informational document.
Sure, totally agree. My only concern is that if it's more than 1,000 days, most of the content in the document anyways is getting outdated. So many recommendations would change with other things. It's better to ship the document like
that's fine. So I'm willing to pull it out, right? Like it's not a problem pulling it out. But there's like this existence proof for this kind of thing. There's like stuff in there that's like close to 1,000 days old. Like there's like this cluster 238, I think. If you look at it, there's like, this intertangled thing of like about 40 documents, I would say. They've been stuck in there like for a very long time, right? And so unfortunately, that's how it is, right? Like, if it's a nominated reference, it's a nominated reference. But if you don't mind pulling it out, I can pull it out like from there.
I guess I leave it to the authors to decide.
Ari Keränen, as one of the authors, yeah, I guess the references we're missing were SNCML and RD, and we did think back in the days that those wouldn't be RFCs way earlier. If we would have known it's going to take 1,000 days, probably would have taken another look on informative or normative references. So that is an option, of course. But I guess it's a matter of having that look, have a chat with our AD. If we can make the change, it's okay. But RD should be ready, definitely less than 2 IETFs from now. Should be going for last call any day now. So also that is an option.
So your recommendation is to keep it and then just wait.
Well, we can see what now happens in the RD. I mean, there's a open, let's say, open issue that whether is close to be closed. And I can see an RD comment coming.
Peter van der Stok. I'm not so pessimistic about the RD as I was 1,000 days ago. But we are now in interop, which have passed very nicely. There are 2 modifications. We have changed the interop spec to the accordingly, and I think we can have good interops according to the specifications, and the last call will not be very far away. And then that will be very quick because we had so many comments before.
So either way, it should not be another 1,000 days. It should be either way we go fair.
So I guess it remains in the RFC editor's queue for now.
Yeah. I think it makes sense to see how this final question on whether RD last call is started in the next few weeks. We'll know that in a few weeks.
Okay.
And if it looks it's gonna go longer, then let's have a look whether we should pull off the normative reference. I think that makes sense.
Okay. Then the last thing on the status since IETF 102, well, we had this presentation from Daniel Migauld on doing IPsec on small devices, and I think we have done 2 call for adoptions in 2 IETF meetings, and then we tried to confirm it on the list. There were some comments from Tero, from Paul Wouters and Henrik, but we never closed the adoption call for this document. So there is not going to be any more updates or presentations at this IETF, but I think this is for the group to see if they have comments or if they think it makes sense to adopt this, please comment on the list. Otherwise, this draft, I mean, it's people come and say, oh, they have this concern, and then the document authors address those concerns, send a new update, but those people then never reply if they are okay. So I guess Zen and I will discuss this and then see how to take it forward. But so far, our thinking is that if people don't comment on the new version, then we adopt it. All right, so this is the agenda for today. Carlos will present TCP usage guidance in the Internet of Things. This was presented in TCPM on Monday, and we'll see what feedback he got. Then it's Rahul presenting 2 things, so the neighbor management policy update and then performance report for 6-low fragment forwarding, which was also presented in the 6-low working group. Rene will do a remote presentation on alternative curve representations, and then we had a last-minute update to the agenda, and Pascal will present the security classes for software updates. Does anyone want to do agenda bashing? Are we missing something? If not, let's move on. Blue sheets. Good. Rahul is the Jabber scribe, and Lijo and Ari are taking the notes together. So Lijo had to leave, so he'll start with the notes, and then Ari will take over. Carlos.
Hello, everyone. My name is Carlos Gomez, and I'm going to present the current status and the last update of the draft entitled TCP Usage Guidance in the Internet of Things. So, first of all, let's take a look at the status of the document. Since the last IETF, the draft has been updated once. The last revision is -04, and this last update intends to incorporate to the document the feedback received in the room in the last IETF, and also it addresses the last remaining editorial to-dos from the authors. Also, we received the review of -04 by Yoshifumi Nishida, who's a TCPM co-chair. Later I'll refer to the review. And also in this same IETF, as Mohit explained, I already gave a presentation in TCPM that was a longer presentation with the goal of providing an overview of the main contents in the draft in preparation for requesting a working group last call. Then we also, in that session in TCPM, we received a few comments by Gauri and David Black that later I'll also present.
I have also read this through, and I will give quite long list of comments, but it will take some time to write them down to an email. So,
could you state your name again for the?
Ilpo Järvinen.
Okay, thank you.
Thank you. Okay, so now let's take a look at the updates in the last revision of the draft. So a first set of updates is in section 423, which discusses use of delayed acknowledgements for single MSS Windows. Here we have added that the peer that a constrained device communicates with may be a general purpose system. That means a system which may not be specifically talking only to constrained devices. And it may be quite typical that such system, in such a system, delayed acknowledgements may be configured through system-wide parameters. And a typical setting for this mechanism will be enabled, meaning that in some cases it may not actually be possible to disable delayed acknowledgements, which is what we would like to, in order to avoid incurring some unnecessary additional delay in communication.
Marco Coelho. So I promised to do the review as well, but that's still on my to-do list. So I try to complete that within a few days. But related to the delayed acts, there are other things also that should be taken into account. So unfortunately, when we are using a single MSS advertised window, then it doesn't play very nicely with the if you turn the delayed acts off, because now when the message or the data packet arrives, you immediately act. And that goes with the zero window advertisement. And now when the application reads the data from the buffer, from the receive buffer, that triggers an window update ACK. So as a return, you get two ACKs, and that's the kind of not something that we want to have. So it's not that clear. And another thing is that when you have a request response kind of a traffic, and now when the request comes, you immediately act, and soon after that you send the response. And if you are using delayed acts, in most cases the act would go together, piggyback with the response. Once again, you kind of send an unnecessary act in that case. So this is not that clear whether it's advisable to turn it off.
Okay, thank you. So, well, it would be great if you can provide your comments also. Thank you so much. So, yes, okay, we have also another set of updates in section 5. First, we have reorganized the content in this section. So sections 5.2 and 5.3 have been swapped in order, and also there have been mostly editorial updates in the current section 5.3, which discusses TCP connection lifetime. Previously, it was split in two specific parts, one discussing short lifetime and another one for long lifetime. However, now the content is mostly the same, but it's been presented in a more natural way, possibly better for the reader. And on the other hand, we have in section 5.2, which provides guidance on the number of concurrent connections used. We have added some actual new content. We have explained now that in order to, using several concurrent connections between the two applications may help avoid head-of-line blocking problems for the application. However, it also may be harmful in congested networks. So considering what we already explained in the previous version of the draft, that each additional TCP connection will consume potentially scarce RAM resources, the overall recommendation is being conservative with regard to the number of concurrent connections to be used. Then finally, we have also an update in the annex of the document. As you may recall, this is the section where we collect details on a number of TCP implementations for constrained devices. And basically the update is that we have removed the section on OpenBSN, since it appears that that implementation was actually mostly based on micro IP, so it was actually quite redundant with that. So we have removed that section from the text and also the corresponding column from this table. Rahul.
Nice to see Rahul Jadhav from Huawei. So nice to see the socket a row getting added here, and it's good that we have removed OpenWSN. One thing that I wanted to check is regarding the RIOT, the interface inspired by POSIX. I've seen the latest APIs and they are indeed POSIX compliant. But there are certain options that are not available. But what I'm trying to say is it possible for you to actually push? We work on 4 of these operating systems at least, okay? And it is very difficult for me to convince my team that LWIP 2.0 takes less than 40 KB or equivalent, approximately 40 KB. So will it be possible for you to push the open source with the configuration that you are checking to LWIG GitHub or something? I don't know what is the right place, but I want to cross check whether for 40 KB, whether LWIP 2.0 can fit in 40 KB of code of flash.
Yes, so the sources for this information are different, are heterogeneous. In some of the cases, we do have some actual references that indicate which is the source for some of these details. In some cases, it could be academic papers, or in other examples, it's more related with information available in some web pages. So what we can do, I guess, is double check again all the sources and make sure that we have the right references in place and hopefully fresh.
Yeah, the reason why I state this is because people have started using this to compare things, you know, and if there has to be a fair comparison, the code size has to be checked on the same platform. Maybe we can do a cross compilation for, I mean, there are ways to do it, get it done. I don't know whether LWIG GitHub is the right place to keep this information.
So, Mohit, when we had done this crypto sensors document, which is now RFC 8387, we did experiments with a bunch of libraries, and we got actually a lot of people offline asking us, how do you compile this library on this platform, that platform, what settings you use? So what I did was I made the configuration. We had 3 or 4 different configurations. One was for least amount of execution time, irrespective of how much memory it consumes. One was for least amount of memory consumption, irrespective of how much execution time it takes. And I put it on my personal GitHub so that people could use the same configuration file to build the libraries. And what I guess Rahul wants is something similar, because he's using this OS for his products or for some of his experiments. So if we do say that this is 40 kilobytes, is there some way to reproduce these results? Whether you put it on your personal GitHub or whether we use LWIG GitHub is another question.
Yes, so in fact, well, some of the details here in the caption are related with the fact that some of these data correspond to having these implementations on different platforms. So in some cases, it may be actually difficult to really have a fair comparison. What we can do is make sure that the references and the sources for this information are really reflecting what's intended. So the data here, the numbers for code size are really not measured by ourselves. So they have obtained, in some cases, from academic papers. In some cases, for example, for Riot, we have the details provided by the main developer of the TCP implementation of Riot. So yeah, we have this problem with heterogeneity here. So I don't know.
Sure. So for LWIP, it says the whole protocol stack on embed. So is this embed folks who reported this number, or because now I see the annex that it says for LWIP 2.0, it says the whole protocol stack on embed. So is it the embed folks who said that this is how much space it takes, or did you do some measurement?
We didn't do any actual measurements.
Okay.
So this was based on results that were found by other people who had done those measurements.
But is it someone's blog, or?
Sorry?
Is it someone's blog, or is it more reliable reference? Or?
Well, I hope they are reliable references, but anyway, we can double check and make sure that we can trust the details. Okay, so then we have a number of comments received after the Internet Draft submission cutoff date. One set of comments was provided by Yoshifumi Nishida, the TCPM co-chair. He sent a review on the mailing list. By the way, thanks a lot for the review. And well, his general assessment was that the draft looks fine and mostly ready, although he gave a number of detailed comments. The first one was a suggestion to cite a TCPM document, which discusses the trade-offs and requirements around RTO algorithm design. So it is useful. We believe it's a good idea to add this reference in a section where we explain that devices that use a single MSS window size or very small window sizes mostly will detect losses after the expiration of the RTO. Therefore, the RTO algorithm in that case will have a significant impact. Then the second comment was a request to provide some additional clarification on why we may need a window size of 5 MSS to get 3 duplicate acknowledgements. Then also he pointed out a typo in section 5.3, and also in the same section he mentioned the problem with the fact that TCP fast open, TFO, may sometimes deviate from TCP semantics in the sense that a packet may be repeated at the application. So this is something we need to discuss here. Also, if we want to handle this problem, we'll need to consider the use of additional mechanisms such as TLS. And finally, he requested also to add some discussion on reducing the TCP keep alive interval. That's in order to avoid the issues that appear when in between the two TCP endpoints, there's a middle box like a firewall that performs some kind of early deletion of filter records, for example, after 5-10 minutes of inactivity. And the idea would be to set the keep alive interval low enough in order to avoid this deletion of filter records. However, this has a cost in terms of some increased consumption of energy and memory, energy and bandwidth resources. By the way, we already gave responses to these comments on the mailing list, and the idea would be to incorporate those into the next version of the draft, which will be 0.5. Then on Monday in the TCPM session, we received also some comments. David Black explained that mentioning TCP-MD5, which is mentioned in the security consideration section, is not a good idea since it's no longer considered a secure option. So the proposed action for this is actually removing the related part. And Gori Fairhurst explained that he had read some part of the document. He said that he would provide more comments. And anyway, his general assessment so far was that it was more or less in good shape for a working group last call. So finally, Yoshifumi, as the co-chair of the TCPM session, suggested that once we have this 05 incorporating all the feedback received, we might want to request a working group last call. So finally, well, since I also made this question in TCPM, I'd like to ask to the LWIG members and also the chairs whether it would be a good moment for a working group last call.
I guess it would make sense to address the comments from Marco and from Rahul, and then all the other comments you got from TCPM, submit another version, and then we see the comments on the list. We don't have to necessarily wait until Prague to issue a last call. So we wait for the next version.
Great.
Any more comments? Okay.
Hello, everyone. I'm Rahul Jadhav. Basically, this presentation is about an update for neighbor management policy. What it deals with is you have neighbor cache entries, and how do you manage those neighbor cache entries? Well, with the star networks, star topology, it was much easier to manage the neighbor cache entries. With bus-like topology, it is slightly more complicated. With mesh topology, it is extremely complicated, and with additional constraints, with additional resource constraints, it becomes much difficult to handle the NC entries. So this draft talks about how do you manage these neighbor cache entries in a mesh topology like 6LoWPAN with a limited neighbor cache size, neighbor cache table. So we have received a good substantial review from Mohit. We have updated the document and pushed the next version. We have clarified a lot of terminology that was used. We have given examples about ripple signaling, PANA signaling, which we make use of for network access. There was one thought that came to our mind, whether we should decouple ripple and PANA from this document and make it more generic. It is possible to do that, but then it is very difficult to give concrete examples in the document. So I would like to check if there's any specific feedback from this working group on this point. If not, we can go to the next point. So the points to discuss. So there, while going through the document and while discussing with several other people and while implementation ourselves, there was one more key thing that came to our mind, whether we should do two things. The document tries to do two things. One is the reservation policy for the neighbor cache entries, and the other thing is the signaling recommendations. There are no signaling changes that we say, but there are some signaling recommendations that the document has added. So we feel now that maybe it is difficult to have all the signaling recommendation, or maybe it is not a good idea to give all the signaling recommendation in this draft. It's better to concentrate only on the reservation policy. Like is mentioned here, there is a fixed table, there is a reason entry that is added by, you need to know what is the reason for the entry into the neighbor cache, and then you can have a reservation-based policy. With this, you can have a stable network, even if the node density varies across the deployments. So we intend to remove the signaling recommendations because it's very difficult to get it generically applied across all the deployment scenarios. In some cases, we might cite some examples, but we are planning to remove the signaling recommendations from the draft in the subsequent version. If the working group has any comments about this, then I would like to know.
Mohit, so I'm not a 6-law expert, but like, don't you have the neighbor cache entries based on the signaling that you receive? Right,
So-
you put something in the entry based on some signal you receive. So even if it's for your specific scenario, at least that's a scenario that you're deploying, and you actually have products that you're deploying. So you could write, this is our specific deployment model, and these are the signals we use when putting things into the cache. These are the signals we use when we remove things from the cache, and it may not be applicable to all scenarios.
Right. So let me give a specific example in this case. Yes, we have a deployment in place which makes use of the implicit signaling. Basically, we make use of ripple signaling to add entries to the neighbor cache. The problem is, even with ripple as a signaling mechanism, if we specify that you can add neighbor cache entries based on ripple signaling, it may be interpreted that you can do that across all the deployment scenarios. One problem is, in case of NSNA or NDP signaling, there is a lot other things that are happening. For example, now we have CGAs, we have APND, we have 6775 update, which is doing a lot of stuff. All this is not applicable with this implicit signaling mechanism. So that was what, I mean, we can cite a deployment, we can cite a specific example, but yeah, that would be too limited in scope, I feel.
So if I, Mohit, so if I understand, your concern is that you are using something on the ripple layer and, you know, making changes on the 6-law layer in the neighbor cache. And this is somehow like you're mixing things between layers.
Yeah. So an implementation one implementation can do something like this. Based on the DIO message, it has decided that the preferred parent is selected based on the DIO message. You also add up a neighbor cache entry based on it. Another implementation can decide to do explicit NS signaling before adding a neighbor cache entry. This is also possible. NS signaling gives you some additional control over other stuff, which ripple signaling alone cannot give.
So someone at the IETF said, sir, I guess some long time ago, that if you do it, it's layer violation. If I do it, it's cross-layer optimization. So
Right. Yeah.
I think if it works for your scenario, put it there and
Okay.
you know, make it clear that this is how we are deploying and this is how we intend to do it. May not be generically applicable, and you need to do some of these things if you are running, you know, devices which have hundreds of, not thousands of kilobytes of memory and flash.
Thank you for that feedback. Then I'll take into consideration this thing, and maybe I'll discuss with other authors on this point as well, which are Contiki developers as well. Okay, the implementation progress. We have an implementation which is almost finished. One of the things that we found during implementation is we are unable to handle NC entries, authentication related NC entries with Contiki, because Contiki doesn't support any network access protocol. One way is to simulate the entries. By the way, we have a private implementation which does all this, but we don't have an open source. What we are trying to do here is we are trying to push an open source implementation as part of Contiki, and this is the issue that we have faced. So I hope it is okay to do this way. It definitely stabilizes the network. To what extent we will be able to report the data by the next meeting.
Quick question. So this network access in Contiki, I guess it doesn't do PANA and
Yes, it doesn't do HAPANA, nor there is an equivalent equivalent protocol to do. Yeah, that's all for. So I have another presentation, right? Yeah. Okay. So this is about fragment forwarding draft. I have presented this previously in a day before in 6-law working group. Well, when we presented this in 6-law working group, please let me clarify before I go into the details of this draft that this is specific to the deployment that we are doing. So consider the numbers, consider all the figures that I'm quoting here only in the context of what we are trying to achieve. These are specific. I'll be quoting specific L2 characteristics. The numbers are relevant only with those specific L2 characteristics. So for people who don't know about fragment forwarding, the existing 4944 allows you to do per hop reassembly. You can, every node sends a packet. It's at every immediate 6 LR, it is reassembled and then subsequently fragmented again and then sent up upstream or downstream, whatever. In case of fragment forwarding, it is possible to have a train of fragments such that the fragment as it is forwarded to the next hop. There is a table that has to be managed by every individual 6LR node, but then the overall memory requirement, the memory utilization for doing fragment forwarding is much less. This has been proved previously by another experiment from Yacht. Yeah, so our motivation, we were really excited about this particular work. We are really excited about this particular work. We wanted to check whether it can improve our fragment forwarding in our scenario. Our primary motivation was to check latency and PDR implication, not the memory utilization on the bottleneck node. And we have been using EAP PANA signaling for the network access, and EAP PANA signaling is relatively bulky, which causes fragmentation in the network. So we were hoping that if fragment forwarding can solve that issue, it will improve our network convergence time. Okay, the test, so we started this implementation even before the drafts were adopted. So we were really excited about this work. We are really excited about this. So the test configuration that we used is, we used 802.15.4 in unslotted single channel mode of operation. It had carrier sensing, it has clear channel assessment enabled, but no RTS CTS. I don't know if anyone here uses low pan with RTS CTS. It has a high control overhead, and no, I don't know of any implementation or any deployment which uses RTS CTS with low pan. The network configuration here is 50 nodes, not a very big network. It's a grid topology. The distance is specified here. We used MRHOF with ETX as a routing metric. Trickle parameters and MRHOF thresholds were all similar for all the tests. Okay, the data transmission frequency, we had a sparse data transmission. We send data every 40 seconds or 80 seconds or 160 seconds. The data payload varies from 256 bytes, 512 bytes to 1024 bytes respectively. The reason why we did like this was so that we wanted to have equal amount of data traffic in the air, but more or less fragments in the air. For example, 160 seconds scenario will generate more number of fragments per payload than 40 seconds. But the amount of fragments in the air at any point of time should remain same. The data traffic in the air should remain same. Please note that there was a random delay between 0.5 seconds to 5 seconds before transmitting each of this payload, not the fragment. And all the data here is destined to the border router. I think that's okay. So the packet delivery rate that we found with fragment forwarding, it actually had, yeah.
Here's a quick question. That random delay, is that in addition to the channel access delay?
This is the delay that is added by the application layer.
It's application layer.
Yes. So the packet delivery rate that we found was surprising, actually. In case of per hop reassembly, we found that per hop reassembly is performing much better. Well, if it turned out that fragment forwarding is better or is almost equal or better than per hop reassembly when there is some sort of pacing involved. What it means is you add, I'll come to this point, what is pacing? So before every fragment is forwarded on the sender side, we would add some fixed delay. It's a fixed delay of 50 milliseconds or 100 milliseconds. Because it is much easier or trivial to implement this kind of delay mechanism on the sender side, it's very difficult to implement such delay on intermediate hops, because on intermediate hops you might have multiple fragments coming from multiple streams. So it's non-trivial to implement it. So on the sender side, this delay was implemented, and we had a great discussion on the design team mailing list to implement this. It improved, the pacing improved the PDR drastically for fragment forwarding. But also naturally it induced some sort of latency, and it was a big factor. The latency was a big factor here. So the reasoning part, the MAC transmit failures, if you see the MAC transmit failures were very high in case of fragment forwarding without any pacing. It reduces if you add some pacing. With per op reassembly, it's much better. But one more point that so the observations here is this: all the observations here are quoted are in context to the setup that we have, and it's not a very generic setup. It's very specific to our deployment. Fragment forwarding seems to depend on pacing. If you add pacing, the latency, and if you add pacing, the latency is negatively impacted naturally. At least in this case, per hop reassembly seems to be doing better, both in terms of PDR as well as latency. The L2, but clearly L2 primitives has a bigger impact than anything else on this whole scheme. So one of the key takeaway from this experiment was that if you are going to implement fragment forwarding without considering any L2 primitives, without considering what your L2 is, you might have some surprises. So it's better to get your L2 characteristics in place before thinking about such a scheme. Fragment drop due to memory unavailability, in our case, at least it was nil. And the reasoning was that we had a great topology. It was a sufficiently balanced network and the traffic patterns were sparse. So not much of a memory issue for us. But if you have a constant fragment, constant payloads going out of the node, then you might run into memory unavailability issues, and fragment forwarding in that case might perform much better. Secondly, one more important thing is fragment recovery might actually help in this case, because we found that as the number of fragments per payload increased, it resulted in exponential decrease in PDR or latent exponential decrease in PDR. So if you have fragment recovery of some sort, which is another draft in 6low, it might actually improve the performance. The simulation tool that the simulation tool that we used was Whitefoot framework. Basically, it's an NS3 LRW PAN in the backend, and there are some implementation quirks that I mentioned. We needed some slack to be added in the first fragment. Yeah, clearly more experiments are needed. There are different RFs that have to be tried out, more optimal pacing algorithms that have to be thought about, and we are hoping to do the same experiment on the actual hardware setup. Thank you. Carsten?
Carsten, more a quick question. If I understand your parameters right, a packet takes about 4 milliseconds to be transmitted, and then we add a little bit of interframe spacing, so we have something like a 5 millisecond wait of a packet. And it's interesting that 50 millisecond is kind of okay, and 100 millisecond is perfect. So what's the relationship between those 5 milliseconds and the 50 and 100? Do we have a hunch? What
No,
that might be?
which 5 milliseconds you're talking about? Are you talking about the actual propagation delay or?
No, I'm talking about the serialization time of the packet. The packet is in the air for about 5 milliseconds.
Correct.
So that means it arrives at the next hop sends it. So if it were able to do this immediately, then the channel would be clear again after 5 more milliseconds.
Right.
But you have to wait 50 milliseconds, or even better, 100 milliseconds. So do you have a hunch what the relationship between these theoretical 5 milliseconds and the real 50 or 100 might be?
So what we think is that the train, the fragment train, you are trying to send as well as receive at the same time on the intermediate LR. That might be causing the issue. So the downstream node is trying to send, as well as the upstream 6LR is also trying to send at the same time.
Yeah, I know what causes the issue. The question is, what causes these numbers? And maybe it's worth actually looking at other numbers and trying to come up with a characteristic there.
Right. So one of the things that we looked at was the MAC transmit failures. Now here only the MAC transmit failures are mentioned. Even the second and third attempts, so we have a MAC retries of 3. The second and third attempts were also relatively much higher in case of fragment forwarding. So what this tells me is, and we had clear channel assessment in this assessment enabled, CCA was enabled, we had carrier sensing in place. Even then, there were a lot of failures with fragment forwarding. So in case of, I think, yeah, what you said is we need to check what caused that failure on at a much granular level. Yeah.
I
What I'm
think we
trying to
need to finish this soon.
one
We are
sentence.
running out.
What I'm trying to say is, this is an interesting result, and it requires some diagnostic work to find out why it is that way.
Yes, thank you, thank you.
So I
Yes,
hope
it
you will
does
have a
require-
presentation next time.
Yes, hopefully, yeah.
Rene, you are up next. Sorry, it's still Rene. Rene, are you going to join? I guess then we can move to the next presentation and come back to Rene at the end. Pascal, go ahead. Please come closer.
From Telecom Paris, kind of ground record in France. So what is about this draft? The goal of this draft, it's a target update for device and let's say Internet of Things device. So the idea is to evaluate the security of the device itself by reduce the number of attributes, let's say 5 Boolean attributes, the firmware loader, one-time programmable memory, secure firmware loader, tamper-resistant key, and diversify key. One question should be, is it necessary to add more attributes? But if you add more attributes, it means you will define a lot of subclass of device. So from this classification, you get 18 device class, let's say 2 classes without bootloader and 16 classes with bootloader. So the class of the device is this set of 5 Boolean attributes, the FLDs, the OTP, FLD-sec, TRT-sec, and div key. So what is the goal of this draft? When you talk about software update, one guy from French National Security Agency say, if you don't have update for IoT, it's not serious. It means nothing will work, and your plan to deploy IoT system will completely fail. So update is needed. But if your update can be cracked easily, then it's more than having no update. It means what you are going to deploy is a potential hacked networks. So it's in this draft, we want to provide a qualitative estimation of risk induced by remote firmware updates according to the device logical and hardware security resources. So the device architecture. So you have a main processor, and in the main processor, in all the processor, you are non-volatile memory. It means it's a memory, and usually it's flash or square program, and it means you can erase this memory or write this memory. And okay, it's non-volatile memory, but it can be erased. And this is quite fundamental because taking a look at what is the IoT today, you will find simply that a lot of devices can be completely erased. So it means you believe you have a bootloader in the device, but it's very easy to simply erase the bootloader and to reflash with another bootloader. That's why the only insurance quality, the only security, strong insurance you may have in a device is the use of one-time programmable memory. And I prefer this OTP term rather than ROM term, because read-only memory doesn't really mean that you can only read the memory. And usually it means you can write the memory with other means. And in normal operating condition, you cannot erase the memory. And so when you use one-time programmable memory, it means you have something like a fuse. I don't say that a fuse is perfect. You can reconnect the fuse, for example. But let's say you have a given insurance that you cannot erase this OTP. And another way to put software in a device is to use physical protocols. You have many physical protocols, serial, parallel, and so on. And these protocols are used to put code and data in the non-volatile processors. And because anyway, you need a communication, at least for the update, you have a communication processor. In all IoT device, you have a communication processor. Sometimes the communication processor, in fact, is merged in the main processor. So it's the same thing. You have a system of on-chip the device, but the communication processor too has the same structures. So to go further, you have a device with two main features. You have a firmware, let's say a bootloader, or you are not a firmware loader. The first thing is to identify why is a bootloader needed. If you are no bootloader, it means you need to use physical processor in order to put the code in your device. It means so we have a lot of physical protocol available for the chip, and it means firmware loader is not something mandatory. You may use a device without a firmware loader, and this will give you, for example, other security property. The existence of physical protocols for flashing the device create a supply chain attack. And supply chain attack today is a very sensitive issue for all the device, including the networking device, the IoT device, and so on. It's been, if you have no permanent memory in the device, you can reflash the code you want to flash in the device. And this is very easy to do during the supply chain process, because it means your device could be handled by many people. And these people will have the ability to, for example, to erase your original bootloaders and to reflash another inside. So you have basically these two kinds of device with bootloader and not bootloader. If you have no firmware loader, it means you may have no OTP, which means in that case you have no minimum device behavior. You don't know if your device is simply your device or not. And there's a kind of device as you have OTP memory, which usually is used to store part of the firmware. So you will have a minimum device behavior guarantee. On the other part, on the left, you have a device that includes firmware loaders, currently called bootloader. And so you have two kinds of devices. Either you have no permanent memory, no OTP. It means, in fact, you have a bootloader, but you will never know if the bootloader is the right bootloader. And through supply chain attack, your device could be modified. And this means all you want to do for update software will likely completely fail. And there's a eventuality. There's the option you have an OTP in the device, and then it means you will have a minimum guarantee about your device behavior. So let's say this draft is more concerned with a device that include a bootloader with and without OTP. Okay, so we start with this device with FML attributes set to true. So you have a bootloader. And so the second attribute, OTP, will give you the assurance that is it possible or not to erase the bootloader. For example, in TE, you have an OTP, and part of the loader, and usually the hash of the public key, is in fact in this memory. So part of the security attribute for TE comes from the fact that you have this kind of one-time programmable memory. And if you Google, for example, microprocessors and a ROM, you will find what you are going to get is the datasheet of a secure element with the datasheet that you could not have without NDA agreement, because generally the specification of this kind of device are not public. So let's say most of processors have not OTP today, only flash memory. And so they use physical protocols to be flashed. And the first code which is flashed is the bootloader. Then the next attribute is the use of secure firmware loaders. That's to say,
Pascal, we are running out of time. Could you wrap it up?
So do you have security or not? Some bootloaders have no security, for example. And it's very common to a bootloader to have no security or not things like that. And even if you put security in your bootloader, the issue is your device tamper resistant or not. That to say that all symmetric cryptography may be broken by side channel attack and asymmetric too. So it means even if you have a secure bootloader, if you have not this tamper resistant key attribute, it means all the key could be recovered by well-known attack, both for symmetric and asymmetric cryptography. There was a competition last year, and the goal was to write a program with IES key inside, and it skipped 6 months, and all the program has been broken, let's say between a few seconds and 3 weeks. So it means there is no way to do today to securely compute asymmetric or symmetric algorithm by software. And the last attribute is a diversified key. It means because you know that you have side channel attack, if you use a hardware without tamper resistant key, if you put, for example, one AES key for all the device, it means the recovery of one AES key will break all your update architectures.
I think we need to do a hard stop here.
And I am finished.
Thank you. So we look forward to more updates. We'll give one more try to Rene and see if it works. We are running out of time. Rene, can you give it one more try? Do I need to press anything?
Hello? Hello? Oh, okay.
Okay, now we can hear you. We are...
Okay, so what I will do is I probably will go to the slide number 4, because I think I have 2 minutes or so. Yeah, this one. No, not this one, the previous one. Yeah, this one, yeah. So I presented this document in Montreal, and since then I think it became a working group document. And there were some missing pieces at the time because I had to run some computations, which actually took quite some while. But the results are included now in the document version 0 that I posted by the cutoff date. But since then, I've also provided a few examples. And the examples have to do with essentially how can we deal with different elliptic curve flavors in a small device, either Weierstrass curves, which are the NIST curves, or one of the CFRG curves, which is either the one used for Diffie-Hellman key agreement or for signatures. And the main crux of the draft is really to try to morph them into something that decreases the code size requirement and also makes it easier to specify new things. So I provided two main examples. One of us, if you have a small device and you run, for example, key agreement on it, like in the COSE protocol, then maybe you can also implement the so-called Edwards signature scheme in which also has been used in the same COSE scheme and also in ad hoc I saw, using the same implementation. And let's go to the last slide. So basically, I show that you can use all these different flavors of curves by whipping them into the same shape. And so that you can use the NIST implementations and reuse them to also implement the CFRG curves, but also to use a single implementation for both the Edwards signature scheme and the Montgomery ladder that's used also in the COSE scheme. The main question I have is, the draft really looks quite technical, and the first 5 pages or so are really what the main content is, and everything else is essentially a huge tutorial into all kind of transformations. So I would really like to have a little bit more feedback. And I already got some good feedback from Nicolas Reusner, who I think he did his thesis on this project. And I also would like to have some implementation insight. So I got some information. Actually, NXP has some technical notes about how to implement the CFRG curves using their kind of old NIST hardware. It's a factor 10 speed up. But it would be useful to see if it has some other uses as well. And maybe also some drawbacks. I put a few in the draft. So main question for me is, when you have a chance, have a look at mostly the non-appendix part of the draft, which is only like 5-6 pages. And it includes a title page. And let's have some feedback and see how we can move this forward and maybe fill some gaps that you may discover.
Rene, we are already 3 minutes over time, so I think it's...
I'm done.
Yeah, it's time to close the meeting, but it's for the group to provide more feedback on this draft. I think it's provides some useful information. Karsten, quick comment.
Thank you, René.
Thank you, Karsten. Okay, so I guess we need a few more reviews before we progress on this document. That's it for LWIG. Where are the blue sheets? We are done for today. Thanks, Rene, and thank you all.
Thank you.